Hello everyone, this is our quick tutorial on probability and the unit normal table. So when you're working on a problem and you're like, wait, what do I do? This can be your go-to reference. So just a quick reminder about the unit normal table, or our Z table. Column A is going to have our Z scores. Column B is going to have the proportion in the body. The body is whatever the bigger piece is. So that's a nice little alliteration there, right? Where we have the B for body, the B for big, and thankfully it is in column B. Column C will be the proportion in the tail. The tail is whatever that smaller piece is. Your unit normal table in your book went ahead and did a favor for you, and it gave you another column, which is the proportion of the area under the curve between the mean and the Z-score. Now, we could already do this. We could already get this value for ourselves because we know that the normal distribution is symmetrical. And so we're going to have 50% on each side of the mean of that distribution. And so truthfully, we could take the proportion in the body and subtract 50% and get that distance between the mean and Z. But your book did you a solid and went ahead and calculated that for you. For different problems, you may need different columns. And so really the hardest part of this is just figuring out which piece of the puzzle you're looking up and what is the best way to do that. Your book lists those in proportions, but you can also turn those into percentages for that percentage under the curve. Remember, this is the probability of having a score in that particular location. Now, the other way that you can do this, you can look at the Z-scores and then look at the individual proportion under the curve. Or you can look at the proportion under the curve, say if we're talking about percentiles, and you can then look at and find the corresponding Z-score. So you can go back and forth with this table. It's a very useful tool. Again, I've given you, if you're in one of my courses, I've given you a truncated version on the back of your formula sheet, but your book has the full one. So you may have a problem that truncated version doesn't have the value for. Go to Appendix B in your book and you can find that unit normal table. You can also just Google a Z table or a unit normal table, and they're all over the internet. They are all the same, but you have one provided for you in your textbook. Another helpful tool is this interactive normal distribution table from Math is Fun. This is linked in your e-learning site, but it allows you to kind of play around with these Z-scores and these proportions so that you can figure out kind of this area under the curve. I do encourage you to play with this first to kind of get those understanding before you work on those practice problems. But don't use this exclusively. Make sure you're using those tables, because those tables are what we're going to be using on an assessment. You won't have access to this. So this is a bridge for understanding, and it is a fabulous bridge. You should absolutely use it if you're having a hard time figuring out that what we're trying to do here. But just make sure that you're also comfortable with using those tables, because we won't have this resource on assessments. So if you were in class, this is our practice with a partner that we did in class. We had 6 different questions that I wanted you to do, and I'm going to go through the answers here as a way to remind us how we could do these different kinds of problems. So the first one we asked was the percentage of scores, or the area below the curve, for a Z-score of 1.3. Again, sometimes the hardest piece is just figuring out what part of this normal distribution we're talking about. So again, I encourage you to go ahead and draw your distribution. Here I've already have it here. Put that Z-score on it. put that mean of 0 on that Z distribution so that you can have kind of your bearings as what is going on with this distribution, where that number line corresponds to on the x-axis. And then the next thing that you need to do is shade in what part of the distribution we're asking you for. Where's this area below the curve that we're interested in? And we said a z-score of 1.3, and we were interested in the area below that. So using that number line, that will be the area below less than 1.3, and that gives us, we're looking at the body, right? We're looking at the bigger piece of that distribution, so we're going to be looking at column B, the body. We also know that z-score is 1.3. So when we look at our unit table, we're going to look only at 1.3. Again, we're interested in the proportion in the body. So we're going to look in that column there, and we get 90.32 is our proportion. Or we can also put that in that percent under the curve, which is what I asked for, and that would be 90.32. So if I ask for area under the curve, that's really what I'm looking for, is that percent. If I'm asking you for the proportion, then the proportion is fine. But again, mostly what I'm interested in right now is just making sure you understand how to use this unit normal table, and you understand the normal distribution well enough to figure out what part of the curve we're asking for. So the next question asked you for the percent of scores or the area above a z-score of 0.4. So now we're not interested in the body. We're talking about above, so we're interested in the tail. Again, I highly, highly, highly recommend you draw this out because it helps you kind of get your bearings as to what we're asking for and what value you are. You always want to include that 0 on that distribution that you draw because again, it kind of grounds it. It gives you where is plus, where is minus, where those things are. So we're asking you for a z-score of 0.4. That z-score is in column A on our table. Again, we're interested in the tail, right? We're interested in that smaller piece of the distribution. And so then we'll have a proportion of 0.3446 or 34.46%. So again, this is just practicing kind of using this table and using this curve and kind of understanding how this works. So now let's up the ante a little bit and do a slightly trickier one. So this one is asking for the percent of scores, the area between two different z-scores. So here we're asking the area between z-score of -0.7 and a z-score of -0.2. Now, if you look at your unit normal table, there are no negative numbers on your unit normal table, and that is because our distribution is symmetrical. And so whatever that value is for in the body for 0.7 is the same value in the body for -0.7. And so you don't have to worry about kind of where those negative numbers are because it's symmetrical. The body proportion will be the same. It's just basically a mirror image of each other. And again, that's where playing with that interactive one can really be helpful because you can look up a negative z-score and a positive z-score of the same value and see how it just flips that proportion in the body versus the tail. So again, I highly, highly, highly recommend that you play around with that to really kind of get some better understanding of what is going on with this normal curve and this percent under the curve to really understand probability a little bit better. So again, we're going to look at two values here, and the area that we're interested in is this area between these two. Now, there is a number of different ways that you could come up with this value. You could look up the proportion in column D for -0.7 to the mean, and then subtract out the proportion from -0.2 to the mean, because we're not interested in that part. You could do tails and subtract that way. I went a rogue way and I went to body. So we can, and either way, you're going to get the exact same value. So I did 0.7. What is that percentage in the body? And in the body, that is 0.7580. So this is kind of all of the things to the right of the negative 0.7 would be this 75.8%. Now, I don't need that whole area. I just need the area between the negative 0.7 and the negative 0.2. So then what I'm going to do, that's 75.80. The next thing I'm going to do is look up that -2. And again, I'm going rogue here. We got to be consistent. So I'm going to subtract out that percent in the body of that 0.5793. That's everything to the right of the negative 0.2. That leaves me with just the little piece that I'm really interested in. So I'll take that 75.80, I'll subtract the 57.93, and that gives me 17.87% area under the curve. Again, if you didn't do it this way in proportion to the body and you did the tails, that's fine. If you did the disproportion between the mean, that's fine. Some of these problems will require you to add things and not subtract things. It really just, these problems are about, again, figuring out how this unit normal table works, figuring out how the normal distribution works, so that we can understand probability a little bit better. So far we've been dealing with z-scores, two proportions under the curve. Now we're gonna flip it. We're gonna say, okay, well, what if I have the proportion under the curve, but I want to know what that translates to in a z-score. So percentiles are a way that works. If you have ever taken a standardized test, you have likely been given a percentile score of where you scored in that distribution of people taking that standardized test. This is also the same way that we do measurement for children. So if you look at, or you know someone that's had a child or an infant, they might say, oh, we went to the doctor and my kid's in the 90th percentile for height. That means that kid is taller than 90% of their peers of the same age. If they said, hey, I went to the doctor and my kid's in the 90th percentile for height, but the 40th percentile for weight, that means that kid weighs more than 40% of the population. So that would be below average weight for someone of that age. And that's not a problem. That's just talking about necessarily what that child's size is. And that's where doctors are helpful there. But that's how percentiles work. So on the number line, we'll have something like 2. The second percentile will be all the way to the left. The 99th percentile will be all to the right on that distribution. So when I'm interested in this 40%, I'm interested in this piece right here. I'm saying, okay, what would that z-score be? Now you can see I already have the answer here for us, but let's go ahead and look that up anyways. Again, I'm looking at the tail because that's what I'm interested in. I want that smaller piece of it. And notice that there are several that could work for what's closest to 40%. For this class, we're going to say to use the one that is closest. And so if we look at the two values, we have either our 0.413 or our 0.3974. Our 0.4013 is a little bit closer than that 0.3974 to that 40%, which would be 0.4000. And so that's the one we'll pick. We'll say this one's the closest, and then we'll look at that corresponding z-score of 0.25. Now notice, this is where putting that 0 on that drawing is really helpful, because if you just looked up this value of 40%, you'd say, oh, it's a z-score of 0.25. But I'm asking you for 40% in the tail on the left side. So I'm asking you for a negative z-score. And so this answer is negative 0.25. Again, this is where drawing this out is very helpful. In class, people would get that 0.25, no problem, but they forgot the negative because they didn't draw it out. We want to make sure we do that because, again, it helps anchor us. Putting that 0 on it particularly helps anchor us as to, is this a negative z-score or is this a positive z-score? Again, that estimate ahead of time can also help us with that, right? Figuring out, is this a negative score or is this a positive score? So this one, throwing some curveballs at you. What if 15% of students got a higher score than you? What would that z-score be? And so again, this is kind of looking at it as a flip side. Remember, this curve equals 100%. If you look at, for any given z-score, the proportion in the body, and you add the proportion in the tail, you get 100 every single time. You get 100% every single time. So what's the flip side of 15? Well, the flip side of 15 is 85 percentile, right? So this is the same thing as asking for 85% in the body, but is asking for 15% in the tail. So it doesn't matter kind of how you do this, you're going to get the same value. Again, I'm interested in that 15% in the tail, so I'm going to look in that 15% in the tail. Again, by drawing this out, I know I'm going to want a positive z-score here, right? So 15% in the tail. Again, I have several values that are close, but the closest is this 0.1492. It's slightly closer than that 0.1515. So this will be my value, and my z-score will be a positive 1.04, I apologize. The last practice problem that we have, switched it up even more, said, okay, well, what if I want to know what are the boundaries of 70% in the middle, right? So where's the 70% in the middle? What are those z-scores equal to? We can do this a number of different ways. Maybe the one of the easier ways just to go, okay, well, this is symmetrical. So if I have 70% in the middle, that means I have 35% on each side. So I'm interested in this central area, but I have 35% between the mean and that z-score, and 35% between the mean and that z-score on both sides of that distribution to equal my 70. So I'm going to look in column D, and I'm going to say, okay, well, where is that closest to 35? Again, this ends up being that same value that we were just looking at. And that's because 35 plus 15 equals 50, which is one side of that curve. And so we end up, I apologize, getting that same z-score of 1.04. But again, I have it on both sides, so my answer is both negative 0.104 and positive 0.104. So again, I encourage you to play around with that interactive table before you work on your homework, just to make sure that you're really understanding how this all works. I encourage you to always draw it out, always shade what you're interested in looking at. And again, those estimates are very helpful. So estimating, remember we talked about in class, and this is in our lecture outline, that estimate rule. We know we have 50% in each side of the curve. We know that it's about 35% between 0 and the first standard deviation, and that's what we're seeing here, right? That's about 35% for that standard deviation of 1. We know we have about 14% between the standard deviation of 1 and a standard deviation of 2, and we know we have about 2% between a standard deviation of 2 and above, or below. So again, these estimates can kind of go, this is what I'm expecting to get as a value, and can be a nice way to check for understanding. Thank you so much, and I'll see you in class.